Good morning, you guys. I hope you're all staying warm today and can enjoy a little bit of time at home, hopefully with some families. So we are going to start a new unit today, and this unit is all going to be on similarity. And before, we spent a long time talking about congruence, and congruence when we're like side angle side where the triangles were exactly the same. Well, it's going to be a little bit different this unit. And so to kind of get us started, we're going to start by by talking about a transformation that we did not talk about before. The transformations that we did last semester were translations, reflections, and rotations. And all three of those transformations didn't change the shape or the size of the figure. Well, today it's going to be different. Today we're talking about dilations, which is a non-rigid transformation, which means non-rigid means it's going to change the size, and it's either going to reduce or enlarge a figure, okay? Reduce, of course, means make smaller. Enlarge it is going to make it bigger. And so clearly these are not going to be congruent, not congruent. Or you could use the symbol that you guys know, and they are going to be similar. Okay, and so similarity is going to be what we're talking about for the next couple weeks. And so let's take a look at these two triangles. First of all, is this dilation a reduction or an enlargement? And the key is going to be looking at the notation. Remember, we have A and A prime. And prime means this is the image, the new figure, and remember the regular one is the original, okay, or called the pre-image. All right, and so because the pre-image was A, the new image is A prime, it's going from this triangle to this triangle, and we can tell that it's getting bigger, and so it's definitely going to be an enlargement. The other thing to note here is this point O. This is called the center of dilation. Okay, and so we're looking at how much bigger the triangles got, but also like the distance away from that center of dilation, so it's important. So when we try to figure out, are these figures getting bigger or smaller, we need to look at what's called the scale factor. And the the symbol or the variable for that is K. And so the scale factor tells you how much bigger or smaller the figure becomes. Okay, and that scale factor is also going to indicate, is it a reduction or an enlargement? And so if we were in class, I was going to have you guys figure this out in groups, but it's not going to work out so well. So let's kind of start with the enlargement. When is it going to get bigger? Think about something that's getting bigger. It's going to like double in size, triple in size, so forth and so on. And so it's going to be an enlargement if K, remember the scale factor, is greater than 1. So does it double? Does it triple? Does it quadruple? Does it get 10 times bigger? All that kind of stuff. So if it's getting those sizes bigger, it's going to be an enlargement. And if we take a look at this diagram, again, we have C as our center of dilation. We can see P here and P prime. So I know this is my pre-image. This is my image. It's going from here to here. I always like to draw in that arrow. So when we figure out this scale factor, think it's always C to P prime. Think of it as new rather than C to P over old, always new to old. Well, the distance from P prime to that center is going to be 5 over the original distance is 2. And you can keep that as a fraction. Simplify it always. But think about it. If you were to turn that into a decimal, 5 divided by 2 is 2.5. And so really what's happening is the triangles are getting 2.5 times bigger. But also the distance from the C, the center, to P, compared to C to P prime, that distance is getting 2.5 times longer as well. So again, it's going to be an enlargement. It's going to get bigger if the scale factor is bigger than 1. So that brings us to the point, what is it if it's going to be a reduction? What is that scale factor going to look like if it's going to get smaller? And a lot of students, their first reaction is to say a negative, and that's not going to work, because if it's like -2, it's going to get 2 times bigger, maybe be a different direction. That doesn't really make sense. Well, in this case, think about it. If it's getting smaller, essentially the scale factor is going to be a fraction, and it's going to be less than 1, but it's also got to be bigger than 0. And so that's a way to say that the K value, the scale factor, is going to be in between 1 and 0. Notice that it can't be equal to 0 in either, or equal to 1 in either case, because if it's multiplying by 1, it's going to stay the same. Okay, so greater than 1 or less than 1, not equal to 1 in either way. And so back to this reduction, again, what that means is it's going to get smaller if it's a fraction between 0 and 1. Think about it. It's going to get half as big, a fourth as big, an eighth as big, so forth and so on. So again, taking a look at our notation, here we have our center. Here's our P, here's our P prime. So we're going from the bigger one to the smaller one. This now is my pre-image, and this one is my image. Okay, so to find again the scale factor, we go from the center to P prime. Well, again, if we want to think new over old, our new length here to P prime is going to be 3 over our original is going to be 6. Let's go ahead and simplify that, divide each of those numbers by 3, and we should get 1/2. And so our scale factor here is 1/2. Think of it as the triangles are getting half as big. Also, the distance from that center of dilation is getting half as long. So let's go through a couple quick examples and figure out, is it an enlargement, is it a reduction? Let's figure out the scale factor before we make this a little bit harder. So again, you want to look at that notation that we had talked about earlier last semester with the primes. So here's P, here's P prime. So this one is the image, this is the pre-image. Okay, you don't have to label that every time, but me personally, what I do is I always put the arrow. Which way is it going? That helps me just keep things consistent. So I'm going from the bigger to the smaller, which means it's going to be a reduction. It's getting smaller. To find out the scale factor, I need to do the new length over the old length. Well, the new length to P prime is 2 over the original length is 3. And I cannot simplify that, so 2/3 is my answer. So again, the triangles are getting 2/3 as big. The distance to that center of dilation is also getting 2/3 as big. Let's take a look at the next one. Look at the notation. Here's my P prime. Here's my P. So it's going from P to P prime. So I'm going to draw in the arrow so I can clearly see it's going from the little guy to the bigger guy. This is going to be an enlargement. Let's find out how much it's enlarging. We're going to go new over old. So the length to P prime, the new one, is 10. Over the length to the old one, regular P, is just 4. Go ahead and simplify those. I know 2 goes into each of them. 10 divided by 2 is 5. 4 divided by 2 is 2. So 5 over 2. It just kind of is coincidentally like the one with the first one. It's not always going to be 5 over 2. But again, think about it. It's getting 2.5 times as big. That's what 5 over 2 represents. All right, last case. We have our P. We have our P prime. So I'm going from here to here. So again, we're getting from bigger to smaller. This is going to be a reduction. Let's set up our new to old. So new over old. So the distance to the new one is going to be, to Q prime is going to be 6. Regular Q is 14. Simplify each of those. Let's divide those by 2. And we get 3 over 7. So our scale factor is 3 over 7. All right, so I hope that's a pretty easy way. You guys are understanding how to determine if it's a reduction or enlargement, how to figure out the scale factor. And so now what we want to do is we want to take this and we want to use the scale factors to figure out missing lengths within these figures. And we're going to do this a lot in this unit. And so I know this is a little hard to see. Let me point this out. C is the center of dilation. Here is your first figure here, this rectangle looking one. And here is another figure. Okay, these are the two rectangles. It's just a little bit hard to see because they're kind of on top of each other. So first of all, let's figure out, did it go big to small or small to big? Well, look at the notation. Here's P, here's P prime. So it's going from here to here, which means that this is a reduction. Okay, so it's getting smaller. So let's set up our scale factor. What you need to do is you need to pick out two sides that you know the information about. So in this case, I know this length right here is the 12.6, and I can see this little arrow here. This length right here is the 7.56. And so those two sides are corresponding sides, so we can use those to set up our scale factor. We're going to again go new to old. Okay, I'll write that in here, new over old. And so our new length is the prime one. That's the smaller rectangle. And we're going to have 7.56 over the old length, which is 12.6. Now, that looks like a pretty horrible fraction because of those decimals. So use that calculator trick that I showed you. Let's go ahead and divide those out. And you get 0.6, and then your calculator can turn that back into a fraction for you. And so your scale factor is going to be 3/5. And so again, think about that 3/5. The rectangle is getting 3/5 as big. The lengths are getting 3/5 as distance away from that center of dilation. So now that we know the scale factor, we can use that scale factor to figure out the missing lengths. So in this case, we know the original length here is 18.4. We don't know this length here, but I do know it's going to be the same as here. And so what we're going to do is we are going to set up a proportion using the scale factor. Okay, so we're going to go 3/5 equals what over what. Now, you want to make sure that you keep these in the right order. So 3/5, again, we went new to old. So what I want to do is I want to do the value on the new one, which is x, over the old length, which is the 18.4. Okay, and this is how I'm going to set up my proportion, keeping, again, new over old consistent on both sides. That's super important because if you flip-flop one side, you're going to get an incorrect answer. So now, a little review on how to solve a proportion is that you have to cross multiply. Some of you know this as like a butterfly method. So what I always like to do, I personally like to always multiply the numbers with the variable in it first. It just makes it easier. So 5 times x is 5x. And 3 times 18.4 is 55.2. And let's go ahead and divide by 5. So our x value is going to be 11.04. So that means the length of this guy right here, and because it's a rectangle, this guy right here is going to be 11.04. So basically we can use our scale factor to figure out how much smaller the side lengths could be, or how much smaller the side lengths get with a dilation, or how much bigger they get. Okay, let's do another one of those. So again, kind of the diagram makes it a little funky to see here. Let me point this out. Here's the center of dilation. Here's our first figure, quadrilateral, and here's our other figure, another quadrilateral. So first of all, let's figure out, is it a enlargement or a reduction? Goes from P to P prime. Again, put in your arrow. Trust me, that will help you not mess this up. And so since it's going P to P prime, I can see it is going to be a reduction. It is getting smaller. And let's figure out how much of a reduction it's going to be. So look where you can see two corresponding side lengths. Well, I can see this length right here is 9, and this one is 13.5. All the other ones, like let me show you what I'm talking about. Like if I picked this one and this one, I can't figure out a scale factor because I have a number and a variable. That doesn't work. I want to see two sides where I have both numbers. So let's set up our fraction again, new over old. Okay, our new length is 9. Our old length is 13.5. Again, let's use our calculator trick. Let's do 9 divided by 13.5 and turn that back into a fraction because it'll reduce it for us. And when you divide that, you get 0.6 repeating. Turn that back into a fraction, it's going to be 2/3. So again, our scale factor is 2/3. The lengths of the sides are getting 2/3 as big. The lengths from the points are getting 2/3 as small to get closer to that center of dilation. So again, let's go ahead and set up our proportions so that we can solve for the x, the y, and the z. And it doesn't matter what we start with. How about we start with x just because? Well, I don't know why not. So when you set up your proportion, again, make sure you go new to old. That's important. If you flip-flop one side, you will get it wrong. So our new length here, our new corresponds with the prime. That's going to be 5 over, we don't know our old one, is going to be x. This one's a little nicer. We can cross multiply here. Again, I like to start with the one that's variable. That's just me. So I get 2x equals 3 times 5 is 15. Divide by 2. So x is 7.5. Now, the other thing that's kind of nice here is you'll notice on the other side, this length is 5. And so because these two lengths have the same, or these two sides have the same length, that means these two lengths also have to be the same. So z is also going to be 7.5. If you want to set up another proportion that's going to look exactly the same and solve it, I promise you'll get 7.5, but I'm trying to make your life a little easier today. All right, last one, let's go ahead and solve for this side and this side, get our y values. So again, I'm going to keep our 2/3. I'm going to keep that scale factor the same and go new to old. New would be the 7 over the old would be the y. Cross multiply it, we get 2y equals 21. Divide by 2, and our y value is going to be 10.5. Okay, so front side is figuring out, is it getting bigger, is it smaller, getting the scale factor, and then in the bottom part, using that scale factor to find unknown lengths. And we are going to do this part throughout the entire unit. When we talk about similar figures and all of that, we are going to be solving for unknown variables. So it's important that you can set up the scale factors and cross multiply those types of problems. All right, go ahead and flip your paper over to the back side. The last thing that we're going to do is put this on a coordinate graph. And this looks like it's going to be a lot, but I promise you it's going to be very, very easy for you. So we have these points. Let's start by graphing them. So I know it's 4 points. I'm going to have a quadrilateral. Remember x comma y. So a is at 2 comma 1. I'm going to go right 2 up 1 and label that as A. B is 4 comma 1. Go right 4 up 1, label that B. C is 4 negative 1, so right 4 and down 1 is C, and 1 negative 1. That means right 1, down 1. That is going to be your D, and go ahead and connect them. It is a trapezoid. Okay, so we have a scale factor of 2. And so I know that's bigger than 1, so I know that this is going to be, sorry, I spelled it wrong. It is going to be an enlargement. Okay, so I know that these are getting bigger. And so the way that you're going to do this is that you are going to multiply the x and the y coordinate by the scale factor. So you're going to multiply each of those numbers by that scale factor. So for A, I'm going to multiply the x value and the y value by 2. So A prime is going to be at 2 times 2 is 4. 1 times 2 is 2. And so you can see I'm basically doubling each of the x and the y value. Same thing for B. Multiply each of those by 2, so B prime is going to be 4 times 2 is 8. 1 times 2 is 2. C prime. Multiply those each by 2. We're going to have 8 and negative 2. And D prime, we're going to have 2, negative 2. And let's go ahead and plot these. I'm going to go ahead and use a different color. So 4 comma 2, little overlap here, A prime. 8 comma 2 is going to be B prime. 8 negative 2 is going to be C prime. And 2 negative 2 is going to be D prime. And go ahead and connect them. So we can see the green one was the pre-image, the pink one is the image. It definitely was an enlargement. A couple things that I want to point out to you. So the image is twice as big as the pre-image. So 2 things changed, and we talked about this on the front side, but it's still going to be here on the coordinate plane. So the pink one is twice as big as the green one, and that's because of the scale factor. The other thing that I want to point out is that each point is double or twice the distance from the origin. Okay, remember your origin is 0, 0. And the reason why it's double the distance is because the origin is always going to be our center of dilation. Okay, just like we had a center on the front side. So like take a look over here at like D. D is this many units away, kind of 1 diagonal. And look at D prime is 2 diagonals away. All right, so again, that scale factor not only makes it twice as big, but it doubles the distance away from the center of dilation. Okay, I'm going to go through a couple more of these just to make sure that you get the hang of it, and then I'll teach you one last thing kind of on the bottom with perimeter. But let's make sure you can handle these with some fraction scale factors because you are going to have that. So I hope you have a calculator at home with you so you can see how to put that in. So in this case, my scale factor is 1/3. I can tell this is going to be a reduction since it is smaller than 1. And so in this case, again, I'm going to multiply each of these by 1/3. And so when you type that into your calculator, you're going to do 9 times. And then the way I type it in is I open up a parentheses and do 1 divided by 3 because a fraction is just a division problem. But I want to be sure to put it in parentheses to tell the calculator, like, hey, this 1/3 is together. Okay, keep that together. All right, so we're going to do that for each of these. So... or you can just have your knowledge of fractions and how to multiply fractions. 9 times 1/3. All you're going to do is 9 times 1 is 9. 1 times 3 is 3. So 9 over 3 is 3. You can do that in your head if you like, or you can use your calculator. It doesn't matter. All right, so 1/3 of 9 is 3. Negative 6 times 1/3 would be, let's see, negative 6 times 1 is negative 6 divided by 3. That's going to be negative 2. There's where A prime is. Same thing for B. 6 times 1 is 6 over 3 is 2. And then 1 times 3 is 3. Divided by 3 is going to be 1. Again, I was just doing those in my head, but if you want to use a calculator, that's fine. C prime is also going to be at 1. And then negative 2. So let's go ahead and plot both of these. So A was at 9, negative 6. That's over here. And you could have done this first. It doesn't matter. B is at 6, negative 3. Or I'm sorry, 6, 3. And C is at 3, negative 6. All right, there was our original. That was our pre-image. And I know my scale factor is going to make this triangle 1/3 as big. So let's go ahead and graph it. So 3, negative 2. Here's our new A prime. Make sure you label that as prime. 2 comma 1, right 2 up 1, there is B prime, and C prime 1, negative 2. Voila. So look at it, definitely got smaller. It also got closer to the origin because the distance from the points are going to also follow that scale factor. So B got 1/3 of the way from the origin. So it's getting closer where B prime is. Okay. All right. Last one, I think you can handle this. We'll do it, why not? All right, so 3 over 2. Careful, it's a fraction, but that fraction is bigger than 1, so this is going to be an enlargement. Okay, if you actually divide that, it's going to be 1.5. So it's going to get 1.5 times as big. Let's go ahead and graph the pre-image. Left or right 0, up 4 is A, 4 comma 4 is B, 3 comma 2 is C. All right, that is our pre-image. Now I know our new one is going to get a little bit bigger, 1.5 times as big. So we're going to multiply each of these by 3 over 2. So A prime is going to be at 0 times 3 over 2 is 0. 4 times 3 is 12, divided by 2 is 6. And I'm just going to do that in my head because these are pretty easy to do. 4 times 3, the same idea. We're going to get 6 comma 6. And C prime, let's see, we're going to get 3 times 3, which is 9. 9 divided by 2 is actually going to be 4.5. That's a decimal. It's fine. We can handle that. 3 times 2 is 6. 6 divided by 2 is 3. Let's go ahead and graph these. So left to right 0, up 6 is A prime. 6 comma 6 is B prime. Now I'm just going to go over to 4.5. So in between 4 and 5. And I'm going to go up 3 is C prime. A little 0.5. You guys will be fine. So you can see it got a little bit bigger and a little bit further away from the origin. Specifically 1.5 times bigger, 1.5 times as far away from that origin. Okay, last one, and then we are done for the day. So we're going to go ahead and talk about perimeter here, and how does that change the, how does dilating it change the perimeter? So let's go ahead and graph the first one, 2 comma 2, here's A, 6 comma 2 is B, 6 comma 4, C, 2 comma 4 is D. So I got a rectangle. All right, here's my scale factor, 1/2. That is going to be a reduction. It's going to get half as big, half as far away from the origin. And let's go through and take half of each of these. So A prime, half of 2 is going to be A prime's 1 comma 1. B prime, half of 6 is 3, half of 2 is 1. C prime, again, 3 and half of 4 is 2. D prime, half of 2 is 1, half of 4 is 2. Okay, that was a nice kind of easy one. And let's plot our points. Here's A prime. Here is B prime. Here is C prime, little overlap. And here is D prime. Okay, so the lengths of the sides got half as big. The distance got half as long away. So last question of the day is talking about the perimeter of the pre-image to the perimeter of the image. So let's start with the perimeter of ABCD. So this is going to be our pre-image. With the lengths of the rectangles, I can see the length of this is 4, the length is 2 here. So 4 plus 2 plus 4 plus 2, because remember there's 4 sides, we are going to have 12 units. Well, now let's get the perimeter of A prime, B prime, C prime, D prime. Well, here our length is 2. This little guy is 1. So 2 plus 1 plus 2 plus 1. Our length, our perimeter there is going to be 6. Well, take a look at that. What's the relationship between the perimeter of the pre-image to the image? Well, you can see it's half as big. And that should make sense. If you are reducing each side by half, the sum of all those 4 sides is also going to be reduced by half. And so that's a really important thing that I want you guys to know. So the perimeter of the image is 1/2 of the size of the pre-image. So one more time, if you are reducing all the side lengths by half, it should make sense that the sum of those side lengths is also reduced by half. All right, ladies and gents, I hope you feel pretty good about dilations today, about reducing and enlarging. I'm going to post a practice assignment for you. Tomorrow, we're going to move ahead to talking about these similar figures more and the properties of these similar figures. So make sure that you get the practice assignment done, and then we'll pick up from here tomorrow. I hope you guys stay warm today and stay safe. I'll see you tomorrow.